Do we have a volunteer to take the Java notes? I mean, I'm sure we have people who could take. Keep an eye on the meeting room. Excellent, thank you. Tsvwg, yeah, in Java. Too difficult. Why can you do that? So we're going to get started with the discussing the agenda for today's meeting. You've all seen the note well. The note well we presented in the last meeting applies now. Have you got a copy of the note well? Well, just go. There you go. That's the note well. Isn't it lovely? But it is important. So observe the note well. Don't speak up if you have IPR that you do not wish to disclose. You give your name at the mic if you have comments. Okay, next slide. This is the agenda for today. We're going to comment on the RTO considered draft in just one moment. Then there's the working group drafts on SCTP. We have 3 of those. Yeah, numbered 1, turn 4. I did that. Isn't that nice? Yes. Yes. Brownie point for seeing that. And then the next slide shows the agenda for the second half. We have individual drafts. We have a few of these, and some of these will be looking for working group adoption, like we noted in the earlier meeting. So we have transport options for UDP. Joel's requested the working group to consider this. We have encapsulation of SCTP packets, which we've talked about previously. And we have 2 FEC frame documents, which also have been requested for consideration for adoption. And we have some L4S drafts, which we've talked about adoption as well. So if you're bored, read some of these, because we'll ask who's read them when we come to the adoption calls. And we have a couple of other presentations at the end. The first one is considerations for high rate links, which we have slides for in the slide deck. And the second one will be a short notice by me on the edge trace DSCP experiments, just to tell you about the tool there that I talked about in MapRGene. Is there anything we have omitted or anything people wish to comment on the agenda? Going once? Going twice? Okay, this will be the agenda we run with. So first, back to RTO consider, just go back to the agenda item. So, first, a very quick word on the RTO consider draft that was discussed in TCPM this week. This draft talks about considerations for adjusting the RTO. Originally, the work targeted TCP with a description of how this panned out to other protocols, and because of the TCP content, it's being considered in the TCPM working group. The note here, just to you people, is this does contain text that relates to all transport protocols, and it will be working group last called here. But do the discussions for this draft within the TCPM mailing list, please. Next up, the SCTP draft.
Hello, I'm here for Michael Tüxen, who weren't able to attend this IETF. And first, I will present stream schedulers and user message interleaving for SCTP. So there were text improvements and some clarification that only messages of different streams are interleaved. In addition, clarification that user consent required on both ends. This means we have interleaving on association level by default, and if you want message interleaving per stream, you have to enable it explicitly. And a clarification that reassembly works separately for unordered and ordered messages per incoming stream. And clarification of the usage of weight and the weighted fair queuing scheduler. This means that if you double the weight, you get the double amount of bandwidth. And we clarified why the user message interleaving is off by default. I have to check my slides. This is because both sides have to negotiate the support. And we added the I-forward TSN chunk to the IMS section.
Okay, for this document, this is past working group last call. Are all the comments addressed in what you've talked about, or are there any remaining comments? Okay. Do you know the status of the draft? Is it actually updated? We will check with Michael as editor on that draft, and we believe, in my own discussions with Michael, that all the issues that were raised have been discussed and addressed. So if anyone in the working group wishes to comment on it, then please make sure you do comment on it, because we'll be progressing this draft. We didn't see major changes. We saw responses to the working group, so we'll issue a new version of this, and then we'll proceed with the Shepherd write-up. So it's your last chance to contribute in the working group part of this process. Okay, next slide, Jack.
So stream SCTP NAT. One clarification, this is not related to WebRTC. I've heard it, but it isn't. So no changes. On our to-do list is to split up considerations for NATs and endpoints and cover the translation from IPv6 to IPv4 and vice versa. We have tried to implement SCTP NAT into VirtualBox, but this wasn't possible. Well, we tried, but we failed. We will see.
Again, this has been around for some time. Does anybody in the working group have questions about this draft? The feedback we got on this draft were the 2 points which look like they're the things on the to-do list. So I guess you're going to get to address these immediately after you've done the previous draft and submitted the final version of that. Okay, that's good.
So last one. Next slide, please. Yeah, status, no changes since the last IETF. Our issues are tracked at the GitHub repository, and comments are welcome. We're keeping this up until all issues are addressed. And I'm missing slide. Okay.
So on this particular one, a reminder to anybody who's come into the working group and not seen this before, the purpose of this draft is to publish a errata and list of issues with a first round of expected changes, which we will then roll into an update of the base spec. So this is an important document to gather together all the experience that we expect to put in those proposed changes. And the procedure we're using in the working group is to try and make sure that we capture everything before we start opening the main document for edit. So please comment on this. Please also send information to the mailing list if you have any other issues that haven't been addressed by this draft that we would expect to see in that update. And see the revised milestones for when that's going to happen.
I think we have another one. Yeah, last one. SCP NCAPs. Yeah, next slide. No changes. And we explicitly describe the handling of embedded addresses in the init and init action. It will be transformed into a 695.1 bis document. We will keep it to address the issues or to mention the problem.
Anybody got comments on this one? Yeah, and that's something that's already been discussed in a previous IETF meeting when we discussed this 2 meetings ago. So I'm surprised if there's new issues come up here. We requested the feedback when we discussed this in detail and went through all the issues was that we preferred an update to the document rather than a list of changes as a separate document. And so that's what we're going to ask for. Ask for a BIS replacement. Okay. Anybody got any comments on other SCTP work while Felix is up live? There appears to be no one coming. Thank you. Well, okay, so the next slide deck is from Joe Touch. We haven't coordinated well with Joe, but I offered to present this for Joe. I also offered Joe to the remote presentation. Joe, are you ready for the remote presentation?
Joe is present on Jabber. Can
you hear me? I'm here.
We can hear you.
Okay. Let's see if I can get the slides back. Okay, yeah, I'll present this if it works.
Call them out, Joe.
Is it working for me to do this? Okay.
We are ready to present your slides here, Joe. So go ahead and.
Okay, so this is an update on the transport options for UDP. Next slide. The status is that the draft is a major update since the last IETF talk. There have been 2 updates that have been published. 04, which added the light option and the alternate checksum. Light is to emulate what UDP Lite does, where only a fraction of the UDP payload is covered by the internet checksum, the UDP internet checksum. And alternate checksum was an attempt to add something like a CRC to be a little bit stronger than the internet checksum. 05 actually adds in one of the suggestions that came on the list to support fragmentation and reassembly at the UDP layer. And adds in a whole bunch of other TCP-like options that turn out to be possibly useful, including things to measure round-trip times, to indicate the maximum reassembly size, etc. There is actually a driving need towards fragmentation and reassembly. The DNSSEC people are up against the limit that's coming up with the next signature to the routes that goes out in a couple of months. They're going to start hitting up against the limit of the minimum expected IP packet sizes, and although they're not ready to transition to this technique yet because we don't have running code that they can use, etc., boy, they really would love to be able to fragment at the UDP layer and reassemble there rather than relying on IP fragmentation, which we all know has a bunch of problems dealing with NATs, as well as potentially getting dropped at intermediate devices throughout the internet. So they think this would be great if we could do it. The implementation progress is as follows. I had a student working on it over the summer. She got, I want to say like 80–90% of the way through some of the basic options. She didn't get into light or fragmentation or reassembly, which is the basic options. Everything was successful that she was working on, but then she left for an internship. So I'm currently looking for another student to take this over. I can hand off the code to anybody who wants to work with it. What we would like to do at this point is request that this be a working group item because we think there's a lot of interest in it. We think the idea is relatively mature. We have some implementation experience that demonstrates that it is, it is useful and it works. I mean, it's actually it's a lot more likely to work in a lot more scenarios than even some of the other TCP option that we have in process right now. It's already a TCPM working group document that's called the extended data offset that extends the option area in TCP. I'd love it if this would be targeted towards standards track because that's where I think it's headed. I know it's like a new thing and all that, but I think this is a very, very useful way of doing things. It provides a lot of capabilities that people have been asking for. It opens up. I mean, everybody talks about ossification of the internet. This is a really good example of unossifying it. So we'd love to have some feedback on that. We'd love to hear what the working group has to think about it, making it a working group item, preferably targeted towards standards track. Next slide. Or do we even have a slide? Oh, real quick overview. It's option space for UDP. It takes advantage of the difference between the IP and UDP lengths to find a space to put the options actually as a trailer rather than in the front of the message. It never delivers the out of band information that's between the two up to the application, which means everything we have found out so far is that this is compatible with legacy endpoints. If you send it to a legacy endpoint, it's just going to drop things on the floor or drop the missing data on the floor, and it doesn't interfere. We are using an option checksum so that if somehow something does something we don't expect, like aggregates packets when it shouldn't, like some of these GRO implementations might be suspected to do, we can detect that sort of mangling that might occur. Okay, it's useful for a whole bunch of signaling, for fate sharing with the packets that you're sending around, soft state optimizations, and GUE and TAPs are interested in it, as well as, like I said, DNSSEC. Next slide. The 05 editions, we have a CRC16 picked out to provide stronger protection than IP checksum. We already did indicate the polynomial. It's the CRC16 CCITT. We don't have a really good reason for picking anything in particular. We'd love to have it be 16 bits, so the whole option is 32 bits overall with the length and the type. But other than that, we're open to arguments to the contrary to pick a different polynomial. But we think we really ought to just pick one. We have light, which is like UDP. We have fragmentation and reassembly. And there was a really cool idea on the list about how to make fragmentation and reassembly something that didn't send corrupted data to an endpoint that didn't support it, which makes it part of a light option where the light says, don't checksum anything. And in that case, if you send this to someone who doesn't support fragmentation and reassembly, they'll get a packet, but they'll get a zero data packet. Now, there are protocols that will interpret that as, hey, I received a packet, so I should, something happened. But most UDP protocols actually require there to be data in the packet to do something. And in those cases, that would allow you to use fragmentation and reassembly to test it to a legacy endpoint, and it would never screw anything up. And that was the thing I was afraid of with fragmentation and reassembly. We got timestamps, MSS option, a whole bunch of other things that might be more experimental. Next. Sorry, next slide. Can we go to the next slide?
I don't think you have a next slide.
I don't. Okay, perfect. Then I'm done. Thank you. I'll answer questions if there are any.
So first of all, questions on the talk or questions on the draft? Has anybody got any questions on the talk or draft?
Can we ask how many people took a look at the draft? Or have seen it?
Show of hands for people who have read this or the previous version of the draft. 2, 3, 4, 5, 6, 7, 8.
Hi, Tom Herbert. So I did read the draft. I think this is going to come down to whether or not this is somehow practical on the internet. I mean, we already have, for instance, in Linux, I believe we'll just truncate that data before handing it to UDP.
That's not correct. It doesn't. It's
not correct. Okay.
So what'll
anyway,
happen is a legacy UDP will just throw away the option data, right? Which is what it should do. That's what we intend it to do. But the UDP stack would, if it's an updated UDP stack, it will interpret that data. The updated UDP stack absolutely gets it from IP. It doesn't have to do anything magic to get it from IP. That was not a modification.
UDP length, right?
Huh?
The UDP length does not include these extra bits, right?
That's what the spec says.
The UDP length, right? The UDP length is shorter than what the overall IP length says, but we didn't have to do anything extra to get that information from IP. When we're handed the segment from IP, we get the whole thing that IP thinks is IP's payload.
Well, right. But my only point is that there are going to be devices and instances, like thinking about some of the things with UDP encapsulation, like the GTSO, where they're not prepared to handle that. So I'm just saying there's going to be edge conditions for this, so it's guaranteed.
Well, what we've got right now, everything that we have tested, and granted, we have not done thorough, extensive testing with thousands of different devices, but everything that we have tested allows the information to go through when it's a relay, and the endpoint simply ignores it if it isn't upgraded, if it's a legacy endpoint. It ignores that extra field, which is in both cases exactly what we think should happen. Now, there's the possibility that an intermediate endpoint could just truncate that information at the end, right? But if it does, we will detect it with the option checksum, and we can, then you can say, okay, well, the UDP tells the user, hey, this is a problem, don't do this anymore. But you've got to, when you're using this, because UDP is not connection oriented, you've got to do something that says, I either know the other endpoint already supports it, or I do something where I know that if all of this extra information gets chopped off, either by an intermediate or the endpoint, it's safe anyway. And that's how we've designed it.
Christian Wittemar. I am really concerned that putting data in this gray area between the length of UDP and the length of IP will open the gate for putting super cookies in packets.
Putting what in packets?
For options, I guess, yes?
Yeah, but it's not just option, because it means that any system, it's an area that is outside of the TLS, that's outside of control, and so which is equally accessible by third parties. So if we start having a logic in which that data is expected to be somehow used by the end system, then we are just creating a channel for super cookies and other stuff like that.
That argument can be put against any transport option, though.
No, that's not the same thing.
I think it is. It's the same as a TCP transport option. We're saying you could invent a new TCP option that nobody's agreed to and do the same.
I mean, my gut feeling is that if I was porting a firewall, I would drop any packet in which there is such a gap.
But that's, there's lots of places where in the internet, people have decided that if it's something that they don't understand, they're going to drop it. But that's, frankly, it's a violation of spec to do that. The way we have designed it, I mean, frankly, if you want to send super cookies through, there's 1,000 other ways to do it besides this. You can't just say, this does not open the door to that. The door's already open.
No, not so much. Not if you are doing something like quick, for example.
Well, we have a checksum in there, and we have other protections. So it doesn't allow other people to just stuff things in there.
Lars Eckert. Hi, Joe. As the chair of Quick, which is one working group that at the moment is busy standardizing a massive number of new things that UDP will be used for, I'm trying to think here if there's anything that in Quick that would benefit from having these options rather than doing it all inside Quick. And I'm drawing a blank, but I also had a beer at lunch. So I think it would be useful if this would make something like Quick work better or have more features or be better for operators or something. I think that would be a pretty powerful deployment angle.
Well, I think
that we should think about. And if there isn't, if it's not useful for something like Quick, then maybe it's not so useful, because that's like the one big thing we're doing recently with UDP.
Well, Lars, one of the issues is we're not doing almost anything that an application layer can't do. The problem is, as with TCP, getting every application layer to do it right, do it cleanly is hard. If we make this a service of the transport layer, then all of a sudden everybody gets to do it without having everybody have to implement it separately. And that's the advantage. So that there are things that Quick is doing right now, like fragmentation and reassembly, that if it could rely on UDP to do that, that's one less thing it has to do.
Okay, the Jabber strike. Bob, did he talk?
Yeah, I don't know what happens if we have two remote participants. Okay, Joe, can you put yourself back in line, and can we take a question from Bob now?
Hi there, it's Bob Briscoe.
Hi, Bob. Speak up.
This is really a response to Christian. I think I would rather sort of rephrase your comments as being not so much this is bad, don't do it, but maybe this is an opportunity to secure that space, to modify DTLS to secure that space, or to optionally secure that space, because just Joe writing a spec to say this is now legal doesn't mean that attackers aren't already using it.
Yeah.
And so saying Joe shouldn't write his spec isn't the point. Attackers could already be doing this
correct.
whether or not Joe writes his spec.
Okay. Bob, you're making a correct point that it's already possible to put data in this gray area between IP and UDP.
And indeed, you're also correct.
Solution for that, my preferred defense would be to just drop any packet that has anything in that gray area.
And you will, if you look at firewall specs, they do.
Yeah, fine. It's just like dropping something on an unknown port. Okay, it's something I can do. The point that Joe was making is that we can do all of that as application options. There's a big difference, is that the application options are inside the security envelope, and this gray area is not. Now, if indeed you made it part of the encryption envelope, then I have no objection whatsoever. But the fact that it's not protected by the encryption envelope gives me jitters.
So can I come back on that?
Go ahead.
Yeah, that's what I said, that if as well as Joe doing this draft, we do an extension to DTLS to include this in the encryption envelope, then I think there's an opportunity here, not a problem. And I would add that firewall, if you look at firewall specs, they do, because I've done this before with the TCP option thing, if the length of the IP datagram is different from the UDP header, there are firewall rules that will drop that. just search for some specs, firewall rule specs. You don't need to even find the firewalls, you just look for the specs.
Okay, we're going to put Joe in line so he can respond. If you want to ask another question, please rejoin Bob.
Yeah, so 2 points. I like Bob's suggestion, Briscoe's suggestion of extending DTLS to include this in what is protected by DTLS. It probably should have been there all along. I also think I disagree with Christian's claim that these are not part of the security envelope. They're absolutely part of the security envelope. The security envelope for IP, like IPsec, would absolutely cover that entire thing. It would not exclude it either. They're in very much the same kind of place as any sort of option space or extended option space. At some point, if you're doing next layer up, which is what DTLS is doing, encryption or protections, you have to take this into account. And if you actually want protection of the UDP header itself, you either have to have UDP header protection security, which we actually have a proposal for that in here, which is very much like TCP/AO. It's a variant of TCP/AO adapted to UDP. Or you have to do IPsec. I mean, it's exactly the same. It's the same in all three cases. And TCP options are not covered by TLS.
Any more questions or feedback? Okay, that's helpful, and we saw the first part of this debate in some of the previous meetings. I'm interested to know who in the room would be interested in progressing a step in this space. Could I? Show of hands? Show of hands, please, if you're interested in progressing something in this space. 1, 2, 3, 4, 5. Show of hands again of people who think we shouldn't work on this. Christian's already spoken. Anybody else wish to note something?
So assuming we figure out how to bring it under protection of some cryptographic protocol, would that increase the interest in pursuing Spectre? I mean, that seems to be the blocking thing for Christian, that DTLS doesn't cover it. Is that bothering anyone else, I guess, is my question.
If it was limited to DTLS and if it was included in the DTLS protected envelope, then I would have no objection. My personal feeling is that saying, hey, but you could do IPsec is just a joke because nobody does IPsec in practice.
So question for Christian, are you as concerned that TLS doesn't cover the TCP options? Because there's no, what's the difference between this and that? And why are you not concerned that TLS doesn't cover TCP options?
I am. That's why we are doing Quick.
Yeah, but my okay. I'm just going to leave my hand down at that point.
From the Jabber room, Bob puts up his hand for doing something in this space.
Right, so that's +1. Everything. Anyone? Okay. We had a little bit of a discussion there, if I can try and summarize. We saw the issue brought up by Christian, this echoed things that we just discussed in Berlin. I think we should have a clearer position on how DTLS should interact with this, whether it should be included, whether it should be treated the same way as TCP, and we should be clear on that. Then we proposed to issue an adoption call to see if the group is willing to work on this as a work item, and we'll separately consider the list of options that will be allowed by the group as that progresses. So the process will be this. We will go back to the author and ask for more clarity on how DTLS should be treated in his opinion. Please comment on the list if you can. When this is clarified and a new ID is released, we will pursue an adoption call to see what people think about doing work in this space. Finally, we'll cover the question of status and which options are included in this working group. So that's the way forward. Is that understood, Joe?
Joe says A-OK.
Excellent. We have multiple ways of communicating with Joe. Thank you, Joe, for bearing with us. That was good to hear that presented by you remotely.
Hello, so I am Vincent, and I want to introduce to you two drafts. So the first one being fake frame extended, which I already discussed in previous two meetings, and the second one being on RLC, a fake scheme that would be usable for this fake frame extended. And then in the last part of this talk, I will introduce a few performance results that we achieved recently. So let's start with this fake frame extended. Just a note to explain and clarify that neither myself nor Ali tried to patent anything in this domain. And we're not aware, reasonably aware of any patent that would apply. And if you disagree, then please tell us. Thanks. Next. Okay, so just as a reminder, what this is about. So fake frame is a specification of IETF meant to add FEC protection to real-time flows, either in unicast or multicast configuration. So this is also adopted by 3GPP within the MBMS specification. And typically, this is something that could be useful for situations where you have many people interested by the same content at the same time in the same place. So you broadcast the content using FEC scheme for protection. If you are sending file, you are using something else. If you are sending real-time flows, then you are sending fake frame. Next. Yes. So just to say and to remind that as it is specified in IFC 6363, fake frame is limited to block cuts. And what we are proposing, next please, is to add the possibility of using another kind of a fake scheme that is based on a sliding and turning window. I will go back on this, so I will skip this slide quickly. We'll see that more in details in the second presentation. So the changes made with respect to previous version of this internet draft is the result of discussion we had with David at previous meetings. So we clarified the fact that this is only an extension to IFC 6363, which means that there is no backward compatibility issue. We do not remove anything, so we just add one new capability, and this internet draft does not obsolete the previous IFC. So we changed a lot the structure, the content, not the structure, but the content of this internet draft. So we used the existing IFC 6363 outline, but we removed whatever section that was not modified by this extension. So this is the same structure, but with many sections that have been removed or simplified. There is some text explaining that there is no change, and therefore whatever was said previously is still valid. But we added new section here and there to introduce this new capability. So the result of all of this rework on this internet draft is something which is pretty smaller compared to the initial version, 18 pages. You have 2.5 pages, if I remember correctly, section on terminology, which is copied and passed, which was important to keep it. So it's much more easily readable. That's all for this first internet draft. Let's switch to the next one.
Comment from David.
So, I noticed you mentioned 3GPP's usage of the existing fake frame mechanism. Do you have any input from 3GPP on interest in this extension?
Okay, this is what I will discuss at the last slide of the presentation. There is currently,
Happy to wait.
yep, okay, we will see, suspense. So next slide. Okay, so this second part of this talk is about this new FEC scheme called RLC, Random Linear Codes, which is something, this is something I think this is the most obvious and generic FEC scheme for this type of convolutional codes. This is the one that anybody would think about first when talking about convolutional codes applied at the application layer. Next. Okay, so this is a FEC scheme. What does it mean? It means that we specify, first of all, the code. So we explain how to do encoding, decoding, what are the techniques that are used, which is in fact pretty simple. I will show you just after. I have 2 slides about it. But we also specify all the signaling aspects, that is to say, how to identify packets, identify symbols, how to synchronize encoder and decoder, all this stuff, which is a bit more complex. This is for lossy networks, which means that, okay, internet is a perfect match for that. This is what we also call near-result channel, but you can forget it if you want. This is a convolutional code, which means that it works with a sliding encoding window. I have an example just after. Next. Okay, so I will introduce you what is a sliding encoding window in 2 slides and very briefly. It's quite simple, in fact. So there is, as I said, a sliding window over the continuous set of source symbols, source packets. In this figure, this sliding window at that time encompasses source 1, 2, and 3 packets. And if I want to create a repair packet, that's pretty simple. I just have to compute a linear combination of those 3 packets. So repair packet 1 is the sum of a certain coefficient times source 1 plus XOR, in fact, a certain coefficient times source 2, and so on. So that's pretty simple. The question is, how do we choose alpha 1, alpha 2, alpha 3, the 3 coefficients? Next. So as the name says, it's a random linear code, which means that those coefficients are chosen randomly. In fact, we are taking advantage of a pseudo-random number generator that is specified in the internet draft, of course, and a seed that is carried in the packet. And thanks to those 2 information, there is a function that is also specified in the internet draft that will tell you which coefficients you should use. So that's pretty easy. And to the repair packet payload, then we add this header that I show in this figure, which consists of the key, a repair key, which is in fact the seed to the PRNG. And then I explain what is the composition of this encoding window at that time. So I specify the ID of the first source packet plus the number of packets. So that's pretty simple. Next. So this is all you need to know for encoding, and decoding is pretty simple. You have a linear system, and it's just a matter of solving a linear system using whatever you want, Gaussian elimination, for instance. Each time I receive a new repair packet, in fact, I add a new equation in this linear system. So it's just a matter of determining whether this linear system is solvable or not. If it is solvable, then you can recover those packets those source packets that have been lost during transmission. Next. So this is a new FEC scheme, but in fact, it's not all that new if you are aware of what's happened previously in FEC frame working group. Well, I specified 2 similar FEC schemes for FEC frame in the past. So this is the third one. This is the same structure, the same methodology. We're not talking about blocks anymore. We're talking about sliding window, but just a detail. There is something which is a bit complex, but I don't have time to discuss this now, but I can come back on this if you want or later on. This is the mapping between source packets and source symbols. So there is a mechanism for doing that. Otherwise, signaling is pretty much the same. There is a big difference, however, in terms of encoding, symbol encoding spaces. In block codes, we have a single space for identifying source packets, the beginning of this space, and repair packets at the end of the space. Here, we need to specify to have 2 different space ID spaces, one for source packets, one for repair packets. But once again, it's explained in the internet draft This is maybe a big change, but it's quite easy to understand and follow. Next. So now the key question, I think, is, does it work? So there are two types of benefits in using convolutional codes for real-time flows. The first one being quite obvious, reduced latency. I say that it is quite obvious because thanks to the way we produce repair packets, we can produce them whenever we want without any constraints. So they are interleaved within the source flow quite naturally. So if there is an isolated packet loss, we can recover this quite rapidly. The second benefit is less obvious. It is an improved robustness when you are dealing with real-time flows. I insist on the fact that it is when dealing with real-time flows, because if you don't care about time constraints, then you can also use a very large encoding block, as large as made possible by the block codec, and it will work very well. But when you have time constraints, then it does not work anymore. You have to restrict those sizes, and then you enter big problems, as we will see later on, just in the following slide. So the intuition for this improved robustness is, first of all, the fact that the encoding windows are overlapping with one another, which makes it more robust in front of long erasure bursts. And the second intuition is the fact that because of the way it works with convolutional codes, the encoding and decoding window sizes are a little bit larger than what you can afford with block codes. And this does make a big difference. Next. So this is the experimental setup. A few words about the experimental setup. So we consider the Ritz-Solomon codes as needle block codes. So this is a needle block code, which means that you cannot achieve better performance using any type of block codes. And we compare, of course, with RLC. All of this is based on working through C-language codecs, both for RLC and Ritz-Solomon. We only simulate transmissions. We assume, and this is something important, that we are considering CBR transmissions. So it means that between the encoder and decoder, we are considering a CBR pipe. So the more repair packet I have in it, the less I can put source packets. So this is what it means. There is a motivation for that. The use case we are considering, 3GPP use case, requires that we have such a CBR transmission in between. But it also makes sense in terms of, well, internet communication, since we cannot afford to add 200% of additional repair packet to a source flow. It's not realistic. Next. So this is a schematic view of the situation. You have the encoder, the decoder, this CBR channel in the middle, 100 packets per second in this configuration. This CBR channel takes as input a loss model. I will explain you what we are considering as loss model. There is something extremely important, which is the fake budget you can afford for recovering from packet losses. So in this experiment, we are considering 240 milliseconds or the almost half a second. The motivation for having such small latency budgets is that we are considering interactive flows, so interactive communications between the two sides. And we have this target on top right of this figure. We have this target quality, which is having at most 10 at the power -3 residual losses after FEC decoding. So you must achieve this goal, no more than 1 packet lost after for 1,000 packets, source packet sent after FEC decoding. And so the key question is, how much repair packets, how much repair overhead do I need to achieve this goal, taking into account those constraints? So that's the key question we want to answer. Next. Next. I will skip this slide. It's not that important. Just one more slide to introduce you the loss models that we considered. Those loss models are the ones by 3GPP, mobility models by 3GPP. There are two types of mobility considered. One of them is for a vehicle passenger, and the other one for pedestrian. And in those two figures, what you see is the the packet losses. So when there is a white space, the packet gets to the destination. When there is a sharp sign, it means that there is a packet loss. So just by looking at what it looks like, you see that in the first case, vehicle passenger, the channel is quite easy because the packet losses are spread throughout the transmissions. Whereas in case of a pedestrian, you are facing big problems because when the pedestrian, when the person walking the street is behind an obstacle, he will stay within this obstacle for quite a long time and it will create a long packet burst, packet loss burst. Sorry. And in each case, there are 4 different average packet losses, 1, 5, 10, and 20%. So that's the mobility channels that we are considering. Next. Last slide, and then we'll have the results. So this slide is just to explain you how to read those figures. So we are considering a fixed loss model. We are considering a fixed latency budget, for instance, 240 milliseconds, as I said before. And we want to achieve this target quality, 10 to the power -3 residual loss max. So for a given channel, average loss rate in the channel, we have 3 boxes. The green one is for RLC codes, and the 2 orange and red boxes are for Reed-Solomon codes. There are 2 boxes because it depends on the way you implement it. It depends whether you are considering a single FIFO to put all the packets you want to transmit. In that case, you will have a packet scheduling that will consist of a bunch of source packets followed by a bunch of repair packets, source packets, repair packets. So it will happen this way. Or whether you are considering 2 FIFOs for transmissions, 1 for source packets, 1 for repair packets, and then there is a scheduler that selects one out of those 2 FIFOs alternatively, and in which case you have some kind of interleaving in the transmission. So we have to consider those 2 options because it's very important for achieving realistic results. So what you can see in this figure is in the y-axis the amount of repair traffic that you need to have in order to achieve this given target quality, taking into account this loss model, this latency budget, and this average loss rate. So this is how you should understand this. And the lower, the better. For instance, in this case, for RLC, it's sufficient to have 23% of additional repair traffic to achieve this target quality, whereas for Reed-Solomon code, we need a bit more, 28 or 39%. So now the result. Thank you. So those results are for the case where we have a very small latency budget, 240 milliseconds. And what is important, I don't want to go too much into details, but what is important is the fact that the red boxes are always significantly lower than the Reed-Solomon results, which means that you can achieve the target quality with significantly less repair packets with Reed-Solomon codes that you can with any type of block code. And this is, I remember, an ideal block code. So you cannot do better than that. As you see on the right part, so the right part is for the pedestrian mobility channels. The left part is for the vehicle passenger mobility channel. You can see for the pedestrian on the right that there are few channels where there is no solution. You cannot support them. So this is why there is no curve, no no red or green boxes in that case. It's impossible. You need to have a larger latency budget, which is the case in the next slide. Okay. So here we have 2 times as much latency budget, which means that we can afford larger encoding, decoding window, larger block sizes. And here you can support some of the pedestrian use cases. But still, once again, you can see that with RLC codes are always better than Reed-Solomon's codes. Next. Do I have 2 minutes? Okay, so I will go to 2. Okay, so I have 2 additional slides on the impact on latency. The result is that latency is much lower with Reed-Solomon, with RLC codes, because you can do that. Well, the latency experience by the destination, by the receiver, depends on the quality of its channel. So this is, we're considering multicast channels. So we have a single source flow that will address all the receivers, some of them having good reception conditions, others having bad reception conditions. All of this is made so that the latency budget is is always respected. But with RLC codes, there are situations with good receivers where the experience latency budget is much lower. Okay, so I don't have time, so I will skip this slide and the next one. Next, okay. So just to conclude, we have running codes for fake frame. We have running codes for RLC. I said at previous meetings that I was expecting to have running codes for the fake frame extension. This is not yet the case, but I did not have enough time to work on it. But anyway, this is under progress. And all of this is non-public. It is not open source code, sorry, but that's life. Next. And so just to conclude now, so those two internet drafts are not finalized, I would say, but they are, the fake frame extension is pretty good, in pretty good situation, pretty good, well, almost ready, I would say. The RLC, well, this is just the first version, so I need to check once again several times so that there is no mistake, but it's not that bad, you can read it. We already have a use case, target use case. This is work that is being carried out by my colleagues from Expo at 3GPP. So we are proposing exactly what I introduced to you this afternoon. We are proposing the same for 3GPP working group that is called Mission Critical Push to Talk. So the goal of this 3GPP working group is to specify walkie-talkie service on top of LTE communication system. So having the ability to discuss with other people in a wide way with existing LTE infrastructure. So you can, of course, talk with the destinations, but in that case, we are considering something which is very ad hoc solution. We will not use fake frame. It's not possible. The timing constraints are far too important to use this kind of elaborated solution. At the other extremity, you have a file transmission, which will be addressed by Flute ALC, something which is quite standard. And in middle, for video communications, the proposal is to use fake frame extended to convolutional codes with RLC codes to do this. The other solution being to use fake frame with Raptor codes. So, last question. Are you interested by this work? Do you believe it makes sense for this group or for IETF in general? Thank you.
I just have, so David from Menos, so just have a quick question, so quick, notice. Actually, in hardware, we are doing this, for high-speed link is done with much lower, latency budget,
yeah,
and it's a must.
Yeah. Except
so,
that.
Why we need it?
No, a physical layer has been using convolutional codes for decades, for sure. Yes. Still, it's not always sufficient to address packet losses. And this is the reason why ALFAC upper layer codes have been introduced.
In nanosecond, we are doing it, not millisecond. Nanosecond, we do all of error correction.
Yeah, but
in 100 gig, you must have it. Otherwise, the link is not working.
Having FEC codes at the upper layer makes sense anyway, even if there is some protection at the lower layer. Sure. Okay. This is one of the conclusions for the 3GPP working group. And I do agree with this. And this is also the reason why I understand
3GPP understand what you speak about the internet and stuff like that. So in the internet, I protect the link layer, and that's it. Everything is protected.
No, but it is a technology that is compatible with internet.
Can I get in sideways here? Oh, really? Let's talk about IPv6 headers and routers between links. Link layer protection will not save you there.
No, this is not. This is done in the physical layer, not connected to the IP layer, nothing.
No. This framework is an IP layer framework. I understand what you're doing is a link layer. What I'm pointing out is that, and unfortunately, it's also in 2020 hindsight a weakness in IPv6 architecture. Concatenation of links does not a complete network path make. Something has to get the packet off the link and onto the other link, and that something can have integrity problems.
Yeah. Okay.
No. This is the end-to-end view. But this is a common question that is asked quite frequently. Yeah.
Hi, hello. My name is Georg Meyer. I'm the 3GPP liaison person towards IETF.
Great.
Excellent.
I can't find that draft on. So I'm not an expert on the issue. First of all, don't kill me. I can't find this draft on our dependency list so far. We keep usually a dependency list where we it makes it easier for us to communicate with IETF which drafts should be pushed and not, or which drafts 3GPP would like to have pushed. What you write here, mission critically push to talk, especially when it comes to video, this is something we should tackle either in this or in the upcoming release. So this is definitely something that is on our agenda with a rather high priority. And I'm not sure if the draft will fulfill the requirements that we are setting, but I think the next step for you guys should then be to create a dependency by referencing that draft in the 3GPP specs. That can be done with a named draft. It doesn't need to be a working group draft, but of course it's easier to convince the 3G guys if it's a working group draft.
Okay, so this work at 3GPP is not made by myself, but my colleagues from Expo, which is perhaps why you didn't find the reference.
I looked for the draft name actually, and I guess I mean, it's currently a new release starting, so it's most likely in the pipeline to be adopted. But I haven't found anything so far.
Sure, possibly. But anyway, now that both drafts exist, they can be easily mentioned in the proposal. Yeah, we will do that. No problem.
I think we'd be keen to hear any questions from the floor or any notes of interest in where this technology might be useful, so that we can understand whether this is a useful item for the working group to adopt. So please feel free just to ask questions on the presentation or whether you think it's applicable. As people are coming to the mic, can I ask you a question, Vincent? We're talking here about a change to a framework to allow convolutional codes which people have known about for decades and applying them at the IP layer, which seems rational as a possibility. If we open the framework to do that, then we could also open the framework to a whole succession of different codecs, different forms. Do you see this as the start of something which the whole family of different internet drafts on this, or do you think that just making that one proposal in this new framework is enough to actually make a real contribution?
This proposal, those ILC codes are clearly the main solution for doing that. They will not fit all potential use cases. There are limits in terms of coding complexity, decoding complexity. This is working pretty well in our use case, target use case, because we are considering data flows that are approximately at most 1 megabit per second, which leads us to consider encoding blocks of size a few tens, 30, 40 more at most. It's not a good solution for doing the same with encoding blocks that would be in the order of hundreds of thousands. So maybe for those use cases, we will need something else. We already have something in mind, but I'm not sure I will come back again in TSV to propose this. Maybe we need something else, another venue for doing that. This is something we have to discuss.
Okay, so for the moment, you think this is the solution to your problem, and you're not asking for a whole number of options?
Yeah, for the use cases we have in mind, yes.
Okay, Matt?
Matt Mathis, I think it's a minor technical question, but it sparked my interest, and I missed it in the presentation. I'm sorry if it was there. Does this coding technique have the property that if I'm later retransmitting frames, I might, in fact, at that point, be able to recover earlier frames because I've got more information?
I don't.
If I'm missing too many frames to repair a hole, potentially I only need to retransmit one frame to complete the.
No, there is no feedback in fake frame. Fake frame is purely unidirectional. That's by design the choice that has been made. So there won't be any retransmission. No feedback either from
you just fail to recover.
But if you have another mechanism for doing that out of bound, then we can. we can produce one more. If you are on time, if the timing issue is not a problem for you, then we can. But there are probably other ways to do that. Yeah.
Lars, so I was AD when FactFrame wound down. I think Magnus actually owned it, but already back then the expertise in this space was pretty thin in the IETF, and I don't think it's grown since then. And so the more stuff we put on the plate here to take on, the more concerned I am whether we have the energy and expertise. So I'm not saying we shouldn't do any of this. I'm just sort of, my feeling is that the community that can actually adequately review this stuff is quite small.
Yeah, but we can also take it the other way around. This is also a good opportunity to bring some expertise
Man, you are so
in this
positive.
domain, and also it is a good opportunity to have IETF work with well, efficient tools, efficient fake schemes, which is not the case today necessarily. So this is
right.
Yeah.
I'm disillusioned ex-air director here, so.
I think again that error correction has to be on the link layer. We have to keep the layer architectures. IP doesn't have to deal with error correction on the
end to end. So
this is my opinion.
Upper layer.
End to end. You have the link layer.
Yeah. No, but okay. Very objectively, it is included since 2005 in 3GPP specifications on operational systems. We have those end-to-end FEC schemes within MBMS standard. So
every layer have to take its rule. So end-to-end overall, I think the link layer have to make sure that the link is error-free. Yeah. And the connection layer, the TCP layer, the UDP layer have to make sure that you don't lose frame, that everything is okay.
Yeah, but how do you manage in that case good congestion?
Vincent, I don't think we need a discussion on the FEC frame architecture, because that's a yeah, there are two different ways to solve this problem very clearly, and there's real advantage in doing stuff in the physical layer, but we have FEC frame as an architecture for the path as well. So I think this is already something we have in the IETF. What I don't know though is how many people were intrigued by this talk and think this is a piece of work that would be interesting. But before I ask that, I'd like to see a show of hands for people who've read this or the previous version of this draft. Okay. Have you got a comment? Please go.
Brandon Williams, Akamai. We're currently engaged in work that would benefit from actually having a standardized format within which to express the convolutional code. So we would definitely appreciate having a standard thing that we can use as opposed to the stuff that we're putting together now. So we'd be interested in seeing this go forward.
Is that what relates to FEC? Would you be looking for a FEC frame-like solution for that?
Yep.
Okay.
If we could express convolutional codes in FEC frame, we'd probably be using it already.
Thank you. Are there other people in the room interested? Please put your hand up if you're interested, if you think this is an interesting area to do work in. Is that the same 5 people? 1, 2, 3. No, there are more people. 1, 2, 3. Okay. We reckon 12. So, David, over to you.
So I was going to ask is, what's the time frame for clarifying the 3GPP situations? I understand what I think I understood from the comments is this has been proposed to 3GPP, but 3GPP has not yet picked it up in a fashion that it would be recognized as a cross-organizational dependency. Did I get that right?
Yeah, so we practically, whenever something gets adopted in our specifications, even on a very early state, this draft is highlighted and comes as a dependency to IETF. So for example, the FEC scheme is on that list. There's a draft from Payload, I guess, or whatever. And so there are several, we have like, I don't know, 15 to 25 open drafts at the moment and all over the releases. So whenever some company comes, brings a contribution and says this is valuable work, and then there's consensus in the room to adopt that, then it gets adopted.
Okay.
And that can be done at the next meeting. I guess this is work from SA4 group. So that could be done, let's say, the dependency could be ready within the next 2 to 3 months, so that we can highlight it officially here, right?
Okay, that's interesting. So in essence, right now, it's a candidate it's effectively candidate technology for 3GPP, and at the next major meeting, the decision is likely to be taken or attempted on whether 3GPP wants to use it.
That depends on the companies who's bringing it in. They need to write a CR where they put this on the list. At the moment, I can't say whether it's a candidate or not. We don't think in that terms, right? We practically just say you can bring a discussion paper or a change request, and then based on the result of this document, this gets in or not. We can talk about this further also after the meeting.
No, I think that's a sufficient answer. But basically, what I was looking for was a time frame in which more information on 3GPP is likely to be available, and the answer is a couple of months or so.
Well, if it's so that they adopt it at the next meeting and they send me an email, then it's
so
right.
I would take let's take the optimistic assumption that Vincent is correct with his colleagues that they will bring it into 3GPP, and that would then tee things up at 3GPP at the next meeting. And the time frame for that to unroll is a couple of months.
Well, as I said, I don't know when SA4 has the next meeting. Once they have it in, the chairman can send me an email, and things can progress from that on. It's no problem. So it's just like somebody needs to highlight it to me that it's in the specs.
And as far as I'm concerned, I will clarify also with my colleague what is the situation exactly on this respect.
All right.
Right, the chairs have decided we're going to do an adoption call list at a future time, but I would like to see a show of hands in the room about people who think we should adopt this as a question. We're not actually doing the adoption call now, we're doing the adoption call on the list, but since we have 12 people expressing interest, I'd like to do a straw poll on whether those people think we could adopt these 2 items as a useful contribution to this working group. Please indicate now if you think that these documents would be interesting to take forward. Show of hands, please. Can somebody count? Count 10. Okay, I'm going to do a second call for asking for people who think that we should not do this particular, adopt these particular drafts and do this particular piece of work in this working group because there is some reason that you want to not do this work. So if you please indicate if you have a strong opinion not to do this work here. And we're going to
Well, not one more question. Vincent, will you be able to help us round up the reviewers for the mathematics that underlies the codes? I'm confident in this community having the expertise on the framework and the incorporation. I'm not confident on the signal integrity mathematics.
Yeah, we have a few people at NCCRG research group that could do this work, this part of the work.
Yeah, so what we're looking for is an independent expert, or 2, maybe 3, at least 1, who is not part of this work, who can check them, who can check sort of the mathematics and encoding and make sure that in fact what you have is in fact a correct convolutional code.
Okay, no problem.
Great.
Anybody in the room want to make a final comment as we say goodbye to Vincent? Right, we will say thank you for your presentation, Vincent. We will follow this up on the mailing list, so do expect to hear from us.
Right, and thank you very much for doing something very unusual. The author revised the draft and it got shorter.
Okay. So now Cone is going to talk about L4S, 3 different drafts.
Yep. Okay, my name is Koen de Schepper. I will talk about the L4S status. Also a little bit of a discussion of next steps and milestones, it seems, to further work on the drafts in TSVWG. Next slide. So first is an overview of the different drafts. The ones in green are the ones which are L4S specific drafts in TSVWG. The first one is the architecture. It's giving an overview. It's an informal draft. Then the second one is about how to recognize L4S traffic in the internet. So it's how to identify the packets. It's with an ECN option in the header. Sorry, an ECN code point in the IP header. Something different. And then the third draft is about the AQM in the network. That's also an experimental draft. And because these are experimental drafts that change the ECN behavior, we have an ECN experimentation draft, which is standard, which is handled by David Black, also in this working group. Other related work are the ICCRG work for TCP Prague. So it's the congestion control, which is safe for the internet, and extensions on the TCP as well, which is then handled in TCPM for accurate ECN. Then the DC-TCP informal TCPM draft is also related because that's the only existing L4S TCP version, let's say. And then there is also the generalized ECN informal draft that supports marking ECN-capable traffic on control packets. So they are also important, but then more for the deployment on the TCP side. And another initiatives that have been taken in the other protocols, let's say, like for instance, QUIC. Ingemar has filed a draft for QUIC to support also accurate ECN. Let's say it's more or less the accurate ECN requirement. And probably also the generalized ECN mechanisms are needed in QUIC to also be able to support L4S in QUIC. Okay, next slide. So just to say, okay, the architecture is about the whole thing. The dual queue itself, that's a dual queue draft. That's explaining the mechanism, and then the L4S identifier is used in that mechanism as a small part. And the others are on TCPM and ICCRG are only on the senders and receivers. It's a TCP protocol itself. Okay. So the status of the different drafts. The first one is the architecture draft. It has been recently, a few sections have been updated. It's the deployment section. So to better explain what are the advantages of the deployability, that it's actually easy to deploy. I will go into more detail in the next slides. Also, policing has been added or further explained. We thank Karen, Wes, and David for pointing that out. And at the moment, I think there are no real open issues at the moment. Okay. So to go a bit more into the details of the deployment. So in a home network or in a campus or on the internet, typically there is one access bottleneck. So if you could make a dual queue deployment there, you get actually most of the benefits already. So it's only at one point that on that one link that you have to support dual queue that you get most of the benefits. Also in data centers, it's possible to deploy because data centers TCP is used there, and it allows you to mix classic and data center TCP in data centers. And also there you can focus first on the main bottlenecks in your network, and where of course traffic is mixed. Different flavors of TCPs are mixed. Next slide. This is an example of such a deployment sequence which is described in the draft very recently. I think Bob just uploaded it a while ago. So it's just to show you, okay, if you in an access link put or activate dual queue, you can use the existing data center TCP at the moment, and in some kind of walled garden controlled environments, you can use data center TCP now. Of course, if then TCP Prague implementations are ready, you can start using it over the internet in general, and the same deployments in your access link can be used for a wider public. Similar upstream and downstream could be separated, so that actually every step already has an immediate value. It's not that you have to wait for somebody else before you can create value, actually. So it's important to know. Any question?
Just a word of a question, really, a clarification question. I thought data center TCP, when it had been pushed through the TCPM working group, was specified not for internet usage. So it should not be used in access links and clients.
That's why I'm saying it should be in a controlled environment. So it's up to a walled garden solution, let's say. It's for an operator who might want to experiment with it. And
yeah, I think we can come back to it at the very end. I was only just wanting clarification.
Yeah. So it needs to be done with the necessary careful isolation from the rest.
So that was Gory Fairhurst as an individual. This is David Black as an individual. Want to just express a concern to pay attention to, which is there's an interesting interaction, I think it's up on the list, where if we've got one bottleneck, and I think one bottleneck that uses dual queue, then everything is wonderful. If you have two bottlenecks in a row using dual queue, interesting things happen because the congestion marks for the low latency queue go through the wrong queue at the second bottleneck. And that's not sort of debate to have now, but rather we will need to pay careful attention on the deployment guidance and the experimentation to see whether this is a real problem and under what deployment scenarios we can control it if it is a real problem.
That's a good point. So this is, for example, for a single bottleneck, when or dual queue hits a normal bottleneck. So if data center TCP hits a normal bottleneck, it will also have drop. And there is currently quite some discussion on whether drop probability is a problem for throughput. So there is work ongoing in ICCRG and TCPM, I guess, to see whether what's the future actually for drop probability, and maybe also this work is definitely important here. I don't think it's necessary to
You have a question from Bob.
Yeah, I think
okay.
there's a good chance Bob wants to respond to me.
Yeah, sorry, there's a bit of a latency there. It was just on the point about multiple bottlenecks. You do sometimes get them, they're quite rare, but we've had this discussion, I think, in TCPM, and the issue is that sometimes you may get a prior non-L4S bottleneck doing ECN marking, and then it goes into the L4S queue in the second bottleneck. And we worked out, certainly for TCP, that will allow that any marked packets to be delivered early, and therefore early out of order rather than late out of order. But then, because following packets are still moving forward the ACK counter, you don't get any harm from that reordering. In fact, you get the congestion marks delivered.
That one's the other way around.
Yep.
Yeah, that one's the other way around. But in any case, I hope the upshot is that we get one of the reasons for running the wide area experiment that we're trying to enable with working on these drafts is to go have a look at how much these snares turn up in practice and how to deal with them.
I think we did quite some thinking about it, like Bob says. If your classic TCP is marked, it gets in the alpha-REST bottleneck, so it gets faster response about congestion for the classic TCP. So, but there might be different. We never tried it, experimented with it really, so it would be a good case for trying this out and see
yeah.
what
I
results
guess it
could be.
depends on how you treat CE at the bottleneck. Okay.
Yeah, it gets priority, so it gets into the alpha-REST queue. So it's also potentially a benefit for the classic TCP. Plus, it's a congestion, so there is no issue with the reordering. But anyway, these are just thoughts that we made, not the real experiment, because it's a complex system and it might have some unsurprising, unexpected surprises. Okay. So the next draft is the alpha-REST identifier. This draft is stable, let's say. An open issue was a question on the list was about how should ECT1 be treated by AQMs, which are now designed, let's say. What should we do, because it's not yet a standard. So the discussion was default, or maybe a consensus was to drop, to avoid unnecessarily classic ECN detection, which is needed. So, but maybe it's needed anyway if there are by that time already more ECN deployments. Optionally, it's configurable, so to also treat it as then ECN, classic ECN traffic. I think it's a recommendation that it could also be triggered, because if we need anyway the classic ECN detection, then it's better not to drop alpha-REST traffic. And then an additional possible configuration is also to foresee alpha-REST treatment on those packets, so to square the drop probability. But that's under discussion, of course, and it's probably good to further discuss on this. Okay, next slide. The dual queue itself, the drafts, it was actually the main focus up to now. So I think we are pretty happy with what we have. So we can support compatibility with classic and data center TCP, window compatibility. We have pi square, which is quite good and quite well is combinable with the dual queue concept. It also helps to get this window compatibility. We added overloads handling, and there is a large number of experiments done with all different combinations. So I think dual queue is a proven concept for data center TCP. There is a Linux open source released, and there is also the plan to clean up the code and to upstream it in Linux. So that is for a wider audience available, let's say, for evaluation. Next slide. The open issues, the two main open issues for dual queue are one which is not so much discussed, but more discussed internally. That is whether these step thresholds for alpha-REST only traffic, whether it should be a step threshold or whether it should be something else, which provides a more gradual probability control. The step threshold has an advantage that it's very simple and it's very immediate. There is no decision or slowing down needed. It might have some disadvantages with on-off behavior, but it depends. So further research is needed there to try what we can do with TCP Prague. Then the other point of discussion, which is more heavily discussed, is about the coupling function, and I think we should separate that in 3 parts. There is whether there is consensus. The first topic is whether there is consensus that classic TCP fairness is about 1 over square root p, which is I think today true, but most of the people are concerned about will that stay in the future as well. The second topic is that the other part of the coupling, so the square that you see there, p square, which goes to the classic, there is another function which goes to the L4S traffic. That's currently 2 times. It's just because data center TCP, even with the square, is twice as window aggressive, let's say, than classic TCP. So now there is a constant of 2. If we make, will that be the same when we have TCP Prague? Maybe we need another constant. And also for round trip time independent, we also might have another constant there or another function. That's still to be discussed. Okay. Next slide. There are a few minor open issues. I think they can be handled reasonably quickly, and they are ongoing. There is the pi square classic AQM. So all pi heuristics have been assessed for that, because pi enhanced has quite some extra heuristics, not only the auto tuning, but quite a lot of other things are in the drafts and in the Linux implementation. So we assess them, and most of them we think are not relevant. But of course, if there are other opinions by other people that believe it should be, some heuristics are important, then let us know it. Another thing that is ongoing is for the pi square API. That means the configuration for pi square currently, also in the pi enhanced. It lines up with the pi enhanced parameter settings for the Linux implementation. But there are quite some dependencies between parameters. For instance, if you change the update time, you have also to change the alpha factors, and there is a lot of things you need to know. We want to simplify it and make them independent. But that's only a better, more user-friendly interface to the users who have to configure it. And then maybe about the time shift value for the shifted FIFO. Some more experimentation can be done there to see what value is optimal. Next slide.
I wondered if you wanted to reserve some time at the end for discussion. Let's just move to the milestones very quickly.
Yeah. If we are late, that's already.
So to set some context too, so at the last meeting, I think there was energy around this in the working group, and on the list we saw good support for it too. So basically thinking that we should go forward and adopt these 3 working group drafts, and we want to figure out when to set the milestones. So I think that's the part of the discussion we want to have today, because we understand there might be some 5G potential for this work, and so there's a need date based on that. And Bob had thrown out sort of late 2017 as a possibility, but we know there's a lot of there's a list of open issues that you were starting to go through, and if the people that said they were interested in this plan to contribute, we're going to have to do a lot of the work on the mailing list in order to make this happen in that time frame. So it can't be silence between meeting cycles and rush to update a draft and then go through some changes at a meeting. We have to really open threads on these issues and drive to a conclusion on the mailing list. So looking for feedback on milestone dates from the room and the people who said they were interested in working on this.
David Black is an individual. I'll take the first item on Cohen's draft. I would like to get this thing, I would like to get these experimentation draft off to our ADs within about the next month. which means that Miriam and I are going to have to work on text in the next week or so after we recover from this week. But I think that's what needs to be done. There's been I've seen no real objections to what's in there, just that Miriam and I need to work the text. We lay the rationale out better. I believe it's reasonable to believe that we'll have ECN experimentation revised and through working group last call by end of April, early May. I'm going to shoot for that. This needs to move. It's holding up a number of other things.
See, Bob, thank you.
And let's make a note for the minutes that Miria was nodding in agreement with that time frame. Although I think in both cases it's subject to our best efforts with what best effort usually means in terms of internet service.
So Bob, I just accepted you if you had something to say.
Hello. There was a little conversation on the list recently with Dave Dolson about what a classic ECN should do if it gets an ECT1, and we were going to write that up, or we said on the list we'll write up the what seems to be the consensus on the list, depending on if there's more argument, into the L4S ID draft. It's really a question for David. Does he think anything needs to be in the ECN experimentation draft about that, considering it's about classic ECN?
I guess that's a direct question to me. I asked that question in terms of devices today that can be configured to maybe get ready in case the TCP prog starts happening on the internet. Honestly, I don't know if that needs to be written up or anything, or if it's.
It depends also on what can be configured, I guess.
David Dolson, I actually meant David Black. That was a question for David Black.
Really. This is David Black. Okay, so I've seen the issue. I will try to make sure that the Java ECN experimentation draft is to open up space to run the experiment, and we're pretty sure we're handing ECT1 to L4S initially, and the draft is reasonably clear on that. So if it doesn't currently encompass what to do with ECT1 if you're not part of the experiment, it's close, because the reason for doing something for ECT1 with ECT1 is the experiment. I'll take a look at that. I'll take a look at the text noted.
So, Gary Fairhurst, individual, and then I'll go over to the chair's desk and start asking questions here. But I have a kind of a little concern about the last one. My question on data center TCP earlier wasn't just random. We don't seem to have a transport in the IETF which we would allow for internet experimentation with L4S. And we do not seem to have a specified transport that we would allow for internet experimentation using L4S. What we're talking about is Prague as well. TCP Prague will have these features. We know that there are issues in data center TCP, some of them are small, for allowing it to be used in the internet, but currently we don't have anything in the experimental track as a transport we'd expect to use with the experiment that we're proposing in Tsvwg.
Yes. So I think we have to have at least one working implementation, let's say, at least an implementation. I don't know whether we need a draft, because there is always this discussion whether congestion control should be defined. But it's not only the congestion controls like accurate ECN and
indeed
the generalized ECN. Those have to be also ready or agreed on, I guess, before we can use it on the internet. Right.
Right. So that's why
the question was: is there a dependency? And
sitting on this side of the chair desk, I would say this is an interesting question. I think probably we need some clarity here. On the other side, I'll see how the working group talks about this now.
I think Miria is going to tell us. Or Spencer.
You did a talk because I'm responsible for TCPM, right? So you're talking about congestion, talking about congestion control mostly, right? Because transport protocols is TCP, so.
Data center TCP would have been fine, except it actually says explicitly, do not use this in the internet, and it doesn't use accurate ECN, etc.
Yeah. So what does the draft currently say? What you should use on congestion control? I mean, the architecture draft.
Currently, it's saying any congestion control which behaves like 1/p, more or less.
Yes, I think
so.
That's just, and probably it makes like in kind of more information reference to data center TCP, right?
I don't know whether explicitly it says that negotiation is required and things like that.
But negotiation
ECN,
is not
of course.
required. So if you have accurate ECN, that has negotiation.
Yes.
And then
Well,
congestion control is like a center-side only decision.
So I don't think the draft itself says puts any limitations regarding to those drafts. But
so given this is an experiment, I don't think we need to propose a concrete scheme. It's okay to define the requirements here and then do the experimentation.
With what? What's the IETF sanctioning? I mean, if we don't need IETF specs, then we don't need IETFs. I suggested we don't get into the rat hole, which is why I went to that light to raise it. But if we want to talk about it, it's fine.
I think the question you ask is, does this block us here to move on? Do we need something to move on, right?
Is this something we should have on our radar as we talk about this adoption call, which we're going to do in a minute?
I'm waiting.
So this is Dave, speaking as a chair now. I'm wondering if a fudge is possible where we have the spec for DC-TCP that has an applicability statement that was written based on what was there at the time, and maybe a line or two of text could say that as part of the L4S experiment, experimental use of DC-TCP as the transport could be part of the experiment.
Maybe we shouldn't have started that, but that is the one which I would really protest strongly about. When we did extend TCP, we explicitly said, there are issues here when you deploy this. Lack of accurate ECN, etc., will come in the way of actually other protocols using this. It's safe in a data center because we know how data center TCP works in a data center, so different kind of worms.
So
Let's be careful as we go forward, that's all.
On this specific point, which is also a TCPM question, we should probably check the draft, because what the draft should say actually is not only use this in a data center. It should say only use it in an environment where you know that you're not competing with like other legacy traffic and you don't know what this traffic is doing. Only use it in an environment where everybody is using this kind of stuff.
Controlled environment.
It's not really controlled because here what we're doing is we have like a second service on the side to like the best effort service we have right now, and currently the L4S service is not used. So it's a new service, and we can expect that everybody who's using this new service is doing kind of the same thing.
Not the people in the experiment who aren't running L4S routers.
Sorry, say it again.
Not the non-L4S routers along the path are the issue. If we only have paths, if we only allow experiments on paths that all routers are L4S, this is not really the experiment that needs to be done. I guess we can summarize that one at the moment. So
I guess if the transport is backwards compatible with drop or based, is that? No.
But it is part of the room with the elephant.
Yeah, Bob might have something to say. He's queued up too.
He just disappeared.
Oh, he just disappeared.
Did the chairs do that? Pac-Man.
So one more. Okay, then I wait for Bob.
I think there's some latency on this. Hand going up and down. I just wanted to sort of make it clear that in the specs we have said that the only case where we say DC-TCP can be used is in a controlled experiment on the internet, and I would agree with Mirja that a controlled environment over the internet is you can think of it like a controlled area that you're not worried about. Also, not only do we say that DCTCP has to respond to a drop by falling back to a more TCP-friendly behavior, but also DCTCP actually does that. The Windows version does it. The Linux version was meant to do it. It had a bug. Koons posted a patch for that bug into the Linux area. It's not yet in the main line, but you know, so we're getting to the point where both code and spec have the main safety features in them. The only one that's left is accurate ECN, and that can be done in a controlled environment because you can determine that you haven't got any servers that aren't in that environment talking to you, so you don't, you know, the accurate ECN part. So I think everything's written down. It's really just a case of can you read it, Gori, and check that you've not still got concerns. Maybe we need to specify more what a controlled environment means or something, but have a look.
In answer directly to Bob, I will, of course, look again in the drafts to check my understanding of this. I've just read the TCP draft. I think I may have opened up a rat hole, which I don't think is actually the main issue. We all know we need a transport to work on this. We all know accurate ECN is cool. We know how dead-sense TCP works. We need a few protocol mechanisms. These things may or may not be a TSVWG item, but they probably be a TCPM. Let's not, I'd rather cut the line on that discussion and just park it saying, we know there are things here, we'll do work here, if this goes ahead.
I just want to make one final comment that's like a very personal comment. I think this is good work, and like I would like to see experimentation here, so we should enable it. And probably in one of the drafts, you have to make a statement that the congestion control is part of the experiment, and that's what we want to look at.
Yep, we can find words to do that. Spencer, what hat are you wearing?
Spencer Dawkins, walking into the hamster hole that David opened up. I just wanted to say that I'm really excited that you're talking about getting the ECN experimentation draft to me really soon, and I will do what I can to make sure Mariga has time to do her part.
Thank you.
Philip Birdley, this is really good stuff. Where you put on the under the L4S architecture ID and dual queue that allow time for one working implementation of TCP graph requirements before working group in our school, do we really need to gate on that? Or could we just do it without having a working implementation of TCP graph?
I'm trying to rapidly fill in the hole I created, so please.
You don't want me to?
Can we punt on that one? Christian.
Christian Wittemer. About the experimentation, the one thing that is dangerous is not so much that you interact with routers that don't do ECN, because in those cases you will get lost signals that will tell you something. The one thing that is dangerous if you interact with routers that do ECN the wrong way, as in the old way as it was specified before. There are a lot of information around that. There are few of those because ECN is not really widely deployed in the backbone or in places like that, as is. But it will be interesting if, as part of your experiment, you found a way to delineate specifically that. How often did I try something, and I believe that I found, I would say, a legacy ECN router on the path? Because that will be an interesting point of data.
I think there are other experiments going on, like Apple having enabled ECN. They can actually say how much traffic there is marked. I don't know what the status is.
Specifically, things that react to your code point by opposition to the legacy code point.
Yeah. Christian, is that a comment on the adoptability of the draft, or is that something to be just done in the experiment?
It's a be done in the experiment.
Excellent. Has anybody got other comments on the adoptability of the draft? And because I want to talk about adoption as the issue.
Oh, right.
He left.
So, lots of people have interest in this, and I myself went to the mic and had interest. So, if there's lots of interest here, is this a good piece of work to do in the IETF? We're going to do a call for people who are interested in doing this work as an adoption call for these 3 drafts. Does anybody have concern about adopting the 3 drafts together and think that we should stagger adoption or that one of the drafts is not yet ready? So please come to the mic or indicate with your hand if you have concerns that one of the drafts is not ready and the other ones should be considered separately. I see no hands. Okay, so we're going to call adoption on 3 drafts together. Please, first of all, indicate by raising your hand if you have read these drafts. Can someone count? 12. Okay, can you please hum if you think the IETF should adopt work on this topic in this working group? Please hum now. I hear a hum. Can you please hum now if you have concerns about adopting this work or think that we should delay adoption, either concerns about adopting it or you'd like to delay? Hum now. Finally, would anyone like to speak about this adoption call that we've just made and make a comment upon it? In that case, the working group will take this to the mailing list to confirm that adoption call. We saw clear consensus to do this work.
For those listening to the audio feed, there was silence heard in response to Gory's call for hums to not adopt or delay adoption.
I have one more comment on the content. So if you add this experimentation section, you can actually give some more detailed advice about how to run the experiment. For example, I mean, like the Apple people do this correctly, like don't enable it for like all your traffic, just like a certain percentage. What's the metrics you need to measure or to detect to figure out that something goes wrong and these kind of things? That would be really good.
So an extra section to discuss measurements about.
I mean, like, yeah, in experimental documents, we very often have the section describing what's the experiment about, but giving more guidance about how to run the experiment would also be good.
Yeah.
And the final thing is, as we adopt these drafts, they become the property of the working group. That means you do have the right to comment on them and take up anything that you would like to discuss. So please use the mailing list from now on to try and help get this document into good shape. We'd like to proceed quickly if we can. We have very close milestones. We'll now adopt them in detail. Just use the list, please. Thank you.
Okay. This is sort of a presentation that was made without a draft, and because it was a fairly short notice, and it is it actually addresses sort of a certain 3GPP input around optimization for TCP and act thinning and that stuff, and it's sort of an appall to see the interest to move, get some work done in IETF to sort of get some kind of a best current practice around how to reduce ACK traffic, mainly. Take the next one. And the problem here is that the congestion control lack overhead can become sometimes a limiting factor, and that applies typically if you have a lot of data in the downlink and you have ACKs in the uplink. And here we have the situation that the ACK packets are generally small, while the data packets can be sort of 1500 bytes or maybe even larger. And still, even though the ACK packets are small, they sort of consume quite large amounts of bandwidth in a radio environment anyway. And the problem is most prevalent if you have asymmetric access. For instance, a time division duplex, you can have 9 slots for the downlink transmission and 1 slot for the uplink transmission. And then the acknowledgements need to go in the uplink slot. And it's not always they can get data from many users in one uplink slot. So that is then the result is that the uplink can become limiting even though the uplink data rate is quite small, even small ACK packets.
So you have just 5 minutes, I'm afraid.
Okay. Can take next one. Yeah. And if we look at the sort of implementation today, if you look at the Linux TCP stack, then you have typically delay acts, which means that every second segment is act. That when you run experiments with between 2 Linux hosts. And handheld devices, on the other hand, they may have lower ACK rate. And it seems to be that they have a different implementation done in the handheld devices to reduce the ACK rate. And the measurements that are done to 1 ACK per 9 segments is measured. Could be possibly even lower ACK rate. So this indicates that there is some potential to reduce the ACK rate already in the terminals or in the stacks. Quick currently seems to have 1 ACK per second segment. And one problem that can sort of spoil performance for TCP is that there is actually sort of devices sort of doing ACK thinning in networks. For instance, if you have a number of ACKs that are sort of queued for transmission, then you throw all but the last ACK. And if you have an older TCP implementation, that might not be a problem. But with newer TCP implementation that sort of implements TCP fast open and extended data options and a lot of other things, that can be a problem because you can break the end-to-end performance. So that is something that we prefer that is not done actually. So, and just to sort of give it short, they have a sort of a radio example with analog beamforming. I'm not going to go into details around analog and digital beamforming because I don't know all the details. But good for me. And the thing is that you can configure the sort of uplink and downlink time slot. If you see you have a lot of uplink traffic, then you can reconfigure it to sort of, for instance, 7 downlink slots and 3 uplink slots. But then you'll waste bandwidth actually. So it's not a very good solution. Digital beamforming can sort of it's something that is sort of in between, and you can sort of schedule many users in 1 uplink slot. And whether you implement analog or digital beamform, that's sort of up to customer request and sort of how you implement it then. And the question is, even though it's configurable, you have the downside that you waste radio resources. And the question is, do transport block protocols need all these ACKs? You can take the next one. And the solution here is, possible solution, if there is any, an answer to a question, how much can the ACK rate be reduced without reducing the performance too much at least? And under what circumstances can it be done? Possibly if you have a very large downloads, then you can possibly reduce the ACK rates. But maybe in the beginning of TCP sessions, maybe you need a higher ACK rate. That I don't know. And there is some previous work around the ACK congestion control, RC5690. And what it has some around the immediate ACKs that are needed for out-of-order segments. But if you have a recent acknowledgement implemented, do you need the sort of immediate ACKs then? That's a question, because you need the immediate ACKs to counter duplicate ACKs. But if you have the time-based congestion detection, then you might not need it. And another one is that doing an experiment with Scream congestion controller, so that if you use packet pacing, then you could do with a more sparse acknowledgement rate. Excellent. Seems that packet pacing sort of stabilizes the bit rate and reduces the coalescing and all that stuff. So it's packet pacing helpful, and packet pacing seems to be deployed more and more. For instance, the quick packet pacing also. I have a question here.
Hi there.
You're up.
Have you finished, Ingemar? I don't want to interrupt you. If you want to just finish. Okay. I think.
Yeah. I'm not quite finished, but the question is applicability to. Is it applicable to TCP? And then here we need to consider the accurate ECN draft. And another issue here with TCP is that it's so. There are already a lot of middle boxes that sort of, in some cases, may trash TCP X. So it might not be useful. That's an open question. With Quick, it's more simple because you have a protocol that obviates mediate, sort of makes middle boxes complicated to implement. And the last question, is there any interest to work with this, for instance, in terms of a best current practice? And this actually is sort of a more input for other SDOs to sort of avoid. To avoid that sort of solutions are implemented elsewhere. Because most of the sort of endpoint that transport protocol knowledge is around here. So
can people make very short comments? We're out of time. So short comments, please. Before we do that, I'd note as an author of the RC 3449, which is the BCP on asymmetry, we cover a lot of stuff in that. So there's a good track record of doing work in the IETF in this space. So other people, would you make short comments?
Okay, a quick comment, Tom Herbert. If you look in Linux, there's this thing called generic receive offload, large receive offload. One of the side effects is it actually will do stretch acts under certain circumstances. I don't know if we ever looked at the protocol implications of that, but it does happen in real life.
Need to dig things some more.
Yeah, so stretch acts are actually pretty common, not just due to LRO, GRO. Windows Stack has been doing that for a long time. It could act up to 32 packets, depending on whether they're like close together. So this is already happening in the network. We should document what the operating system stacks are doing and whether there is an opportunity to coalesce acts so that the sender can actually account for the coalescing in a more clear fashion so that it knows that that's happening, so that it can account for RTT measurements, congestion window growth. Some of that today we have to like deduce. So it would be better if we could negotiate, for example, coalescing rate or something like that.
Yeah.
Yeah, I can just, that's true. And like there is work ongoing in TCP, so that's good. For Quick, I think there's actually nothing defined yet. So what Google's implementing is every second act, but that's under discussion. I think there's even an issue in Quick. And I don't think this is something we can discuss at the moment in like a transport independent way. It really depends on the transport. And so I don't think there's any chance for a BCP at this point because we don't have too much general experience about this.
But there's a BCP on the act destination, compaction, and all that other stuff already. So we may be able to perhaps add to that. Well, just let's talk more. And take Mira's comments into consideration as well on that. We got a last comment from someone?
Okay, I think Bob's in the queue and
Yeah,
someone after that.
Bob's been cut, I'm afraid.
But I was in the queue first. Gary, I was in the queue first and everyone else went
all right, so this is two, we'll go for it.
Can you hear me?
Yeah, go for it.
Yeah. I think it's important work because, but I just want to make sure the SAC is also covered in this study. Lossy environment SAC probably will be much 10 times bigger problem coming back from the handset device. So I just want to make sure when you talk about ACK, you also cover the SAC as well, because for not of transport, SAC is generated by a different set of rules.
So if there's interest in this, please talk about it on the list and follow up with Ingemar, and we'll see more of this on the next IETF perhaps. Thank you ever so much for coming. understand this. I want to do what